Initial results and discussion. Results were provided using MATLAB's visual and plotting functions. To better understand the frequency, or popularity, of the two search terms for each time period during the experiment, some baseline descriptive statistics were calculated. Box plots are a convenient way for visualizing the interquartile range, average and outlier data. Figure 7 to 10 represent box plots for the 3-hour experiment windows from Saturday 5 p.m. to 8 p.m., Saturday 8 p.m. to 11 p.m., Sunday 1 p.m. to 4 p.m., and Sunday 5 p.m. to 8 p.m., respectively. Box plots for NFL vs. World Series time between tweets, Saturday 5 p.m. to 8 p.m. Box plots for NFL vs. World Series time between tweets, Saturday 8 p.m. to 11 p.m. Box plots for NFL vs. World Series time between tweets, Sunday 1 p.m. to 4 p.m. Box plots for NFL vs. World Series time between tweets, Sunday, 5 p.m. to 8 p.m. Reviewing the box plots in Figure 7 to 10 reveals a couple of interesting trends. In most cases, outliers outside of the interquartile ranges exist, however, as a sporting event gets closer to start time, the frequency of tweets increase. Note the narrowing of the boxes for both the NFL and World Series plots during or approaching the actual game events. By Sunday late afternoon, there was significant activity in both the NFL and World Series tweets in terms of frequency. The descriptive statistics were very similar, making it difficult to see any difference, in terms of tweet frequency between NFL and World Series fans. MATLAB was also used to plot the time between tweets for each collection period and search query. This view, although somewhat cluttered, can be used to quickly compare the number of tweets and any other patterns obvious in xyplot. The time between tweets is plotted in figures 11 to 14, for each of the 4 collection periods. The most revealing information from these plots is the noticeable increase in the number of tweets as the events draw closer. On Saturday, the number of tweets related to the World Series was higher than NFL tweets. This seems reasonable since a World Series game took place on Saturday but no NFL games occurred until Sunday. On Sunday, with multiple NFL games taking place, the number of NFL tweets was larger than World Series related tweets. However, the number and frequency of World Series tweets was also high due to the Sunday evening World Series event, but not as significant as the NFL related tweet activity. xyplot for NFL vs. World Series time between tweets, Saturday 5 p.m. to 8 p.m. xyplot for NFL vs. World Series time between tweets, Saturday 8 p.m. to 11 p.m. xyplot for NFL vs. World Series time between tweets, Sunday 1 p.m. to 4 p.m. xyplot for NFL vs. World Series time between tweets, Sunday 5 p.m. to 8 p.m. The histogram functionality within MATLAB was used to get a better idea of the quantity and length of the time between tweets for each of the collection periods. As shown in figures 15 and 16, on Saturday, the number of tweets with time difference values less than 10 seconds was much greater for World Series than NFL tweets. In all histograms, a handful of tweets had a time between tweets of greater than 100 seconds. The shift to NFL interest is very visible on Sunday in the histograms shown in figures 17 and 18. Note the significant increase in both the number and quantity of tweets occurring in less than 10 seconds intervals for NFL tweets. However, the histograms for Sunday late afternoon and evening reveal similar results for the time between tweets for both NFL and World Series texts. Histogram plot for NFL vs. World Series time between tweets, Saturday 5 p.m. to 8 p.m. Histogram plot for NFL vs. World Series time between tweets, Saturday 8 p.m. to 11 p.m. Histogram plot for NFL vs. World Series time between tweets, Sunday 1 p.m. to 4 p.m. Histogram plot for NFL vs. World Series time between tweets, Sunday 5 p.m. to 8 p.m. Twitter queries provide additional data beyond the time and text of the tweet. For example, the number of friends, number of followers, user screen name, date of account creation, and time zone of user are also available and easily extract from the queries. This information can be used to determine if any significant differences or similarities exist among users of Twitter. Within MATLAB, scatter plots can be used to visually identify clusters of data. Figures 19 to 22 illustrate the use of scatter plots to compare the number of friends and number of followers for NFL, blue X's, and World Series, red circles, tweeters during each of the 4 data collection periods. Although a significant amount of overlap exists in the groups, particularly for small numbers of friend and followers, outliers can be identified in all 4 plots. Additional variables and analysis may be needed to further isolate these groups. Scatter plot for friends versus followers, Saturday 5 p.m. to 8 p.m. Scatter plot for friends versus followers, Saturday 8 p.m. to 11 p.m. Scatter plot for friends versus followers, Sunday 1 p.m. to 4 p.m. Scatter plot for friends versus followers, Sunday 5 p.m. to 8 p.m. Running the k-means algorithm in MATLAB for the Twitter feature sets further reveals the similarity in both NFL and World Series sets of tweets for all 4 time collection periods. Figures 23 to 26 illustrate the results of the applying the k-means algorithm for 3 clusters. In all cases, one very large cluster with silhouette values very close to 1 is observed. However, the other 2 clusters are very small with both negative and lower positive silhouette values. This indicates that the separation into unique clusters is difficult for the set of data and features. Additional selection of features and analysis would be needed to better identify clusters of similar Twitter users. Silhouette plot of NFL versus World Series tweet features, Saturday 5 p.m. to 8 p.m. Silhouette plot of NFL versus World Series tweet features, Saturday 8 p.m. to 11 p.m. Silhouette plot of NFL versus World Series tweet features, Sunday 1 p.m. to 4 p.m. Silhouette plot of NFL versus World Series tweet features, Sunday 5 p.m. to 8 p.m. Hierarchical clustering provides an additional visualization of possible cluster separation for the tweet data. In all cases, the number of cluster and representatives within that cluster matches the k-means clustering results. Specifically, one large cluster was identified along with at most 1 or 2 very small clusters as illustrated in figures 27 to 30 where the left portion of the tree has many nodes whereas the right portion just has 1 or 2. The size of the cluster grows over the collection periods with the final collection period on Sunday resulting in the largest cluster with the least amount of additional clusters. For example, on Sunday, the tree's one small branch is evident on the right side of the graph with a larger branch on the left side containing most observations. Hierarchical clustering of NFL versus World Series tweet features, Saturday 5 p.m. to 8 p.m. Hierarchical clustering of NFL versus World Series tweet features, Saturday 8 p.m. to 11 p.m. Hierarchical clustering of NFL versus World Series tweet features, Sunday 1 p.m. to 4 p.m. Hierarchical clustering of NFL versus World Series tweet features, Sunday 5 p.m. to 8 p.m. MATLAB's neural network toolbox was also used to cluster the tweets through the self-organizing maps function. A hextop topology of 10 times 10 nodes was selected with 200 training epochs. After training, several visualizations are available to help determine how the input is distributed across the nodes. The locations of the data points and the weight vectors are shown by selecting the weight positions plot. With this display, only 2 weights can be shown at one time. Shows that most of the data points cluster in one area and they are not very well distributed. This type of clustering was observed in both the hierarchical and k-means results. SOM weight positions, Saturday 5 p.m. to 8 p.m. The SOM neighbor weight distances plot, using multiple dimensions, provides more information. In figures 32 to 35 SOM neighbor weight distance plots are displayed for each of the 4 time collections. The following diagram colors and description should be used when interpreting these plots. Neurons are represented by blue hexagons. Red lines connect neighboring neurons. Dark colored regions represent larger distances between neurons. Light colored regions represent smaller distances between neurons. Figures 32 to 35 show one large cluster, with small distances between the member records, present in all 4 collection periods. 1 or 2 very small clusters are also present, with relatively large distances between the member records. SOM weight distances, Saturday 5 p.m. to 8 p.m. SOM weight distances, Saturday 8 p.m. to 11 p.m. SOM weight distances, Sunday 1 p.m. to 4 p.m. SOM weight distances, Sunday 5 p.m. to 8 p.m. The SOM weight plane plots are used to visualize the strength of weights that connect each input to each of the neurons. For our experiment, 5 inputs were used, therefore, 5 subplots were generated for each experiment. The 5 input features included, for each tweet, the number of user mentions, URL mentions, hashtag mentions, followers, and friends. Lighter colors in the plots represent larger weights whereas darker colors represent smaller weights. Similar connection patterns of the inputs indicate a high correlation. Weight plane plots are shown for each of the collection times in figures 36 to 39.